Can you remove this? Okay, it's not here. That's fine. So, good afternoon. So I think sessions have been pretty interesting. Clark has talked about gaming. We've seen Siddharth, right? Siddharth talking about virtual worlds. Again, from a gaming perspective, we've had Jatinder, right, talking about corporates, enterprise simulations. So we are a startup based out of IIT Kharagpur, Bangalore, and Dallas, and we essentially we are focusing on engineering and technical education and trying to kind of create virtual labs there. Okay, still not talking about gaming, but talking about how virtualization, immersive virtualization can really help hands-on learning, can complement hands-on learning. That's what we are trying to do. So. Okay, so just a little bit of, how do we view learning as, right? So typically, how does learning happen? For example, you are listening to me, talk, right? So you learn while somebody's talking. Like, for example, in a typical classroom setting, right? And for example, you learn while reading books, okay? You learn while watching videos, okay? But most of these learning forms, reading books, hearing me talk, etc. These are mostly what is known as passive learning, okay? Because the moment I step out of this room, you're not going to remember more than 10 to 20% of what I said, okay? Because why? Because you've not been involved in the learning process. You've just been a passive listener or a passive doer. Similarly is when you read a book, okay? For example, when you read those boring engineering books, you probably don't even remember, 5% of what you read. So, but what research says is, the way people learn and retain better is when they participate in hands-on workshops, they design as opposed to read, or when they simulate, they can model, or they can experience a lesson. Okay, so that's what is known as active learning. And as an organization, we are trying to create technologies for active learning, build products for active learning, because we believe that most of the learning components that are there today are kind of fairly passive, okay? And what exactly do we do? Be it classroom teaching today, or be it books that you read today, or be it video lectures that you see, it's online learning, etc. That all of these things are passive, okay? Because you end up reading, you end up watching a video without actually practicing what you set out to do, okay? So that's where we've kind of built technology to change that. So also what we feel is that, for example, if you look at engineering, people have put in some amount of lab to make practice happen, but lab is just probably 10 to 15% of what you learn in theory. For example, typically if you look at the engineering curriculum, maybe 1 credit is given for a lab and kind of 3 credits for theory, okay? Which essentially, when you look at a lab, we typically as constructivists, we say that learning in a lab is neither reflective nor is it constructive. What that means is when I, as a student, I go to a lab to practice, my focus is only to get the lab work done, get my results. For example, if it's electronics, I want to just get my circuit and my results ready. If it's computer programming, I just want to get my program working, get my marks, and get out of the lab. What happens in a situation like this is I'm pressurized to perform in a particular time environment, that is 2 hours in a lab in a week. So learning goes out for a toss. I don't learn. I don't know what happens if I change this. If I were to use something else, if I were to do the design in some other way, what's going to happen, etc. So we say that, the way the entire thing is constructed today, the way the entire curriculum is constructed today, people are offered very limited practice. As a result, what happens is, their fundamentals are weak, because things like lab time is limited, lab equipment is limited, stuff like that. So people don't really get to practice the theory that they learn in a very effective way, okay? So this is what essentially as an organization we are trying to change. What we've done is we've built hands-on learning solutions, using simulations. Why simulations is because you cannot give them physical hands-on learning solutions and you cannot scale it to millions of students. You have to build immersive solutions using simulations which you can scale up to a lot, the kind of numbers that we are looking today, not only in India but also outside India. Okay, so we are a startup, with our core competency on mathematics, mathematic modeling, mathematics simulations, and we are trying to use that expertise to actually develop simulations related to different courseware in engineering. Okay? So, for example, before I just go into some examples, what we've done is just to tell you where something like this, something like virtual labs actually fit in, right? So we've got colleges which use virtual labs as a pre-lab and a post-lab measure. Okay, so for example, we don't say virtual labs are going to replace physical labs, but they should complement real labs. For example, let's say you have an analog electronics lab. Okay, the whole idea is for the student to actually do the lab exercises virtually before they go to the physical lab. After they do the physical lab, they should come back and do multiple more assignments on the virtual lab, okay? So that they could change components which they weren't able to do in the physical lab and try and learn more, okay? Then we've been able to effectively use it in online learning. For example, UC Berkeley, distance education is one of our customers, where we work with them to provide virtual labs for online technical courses. For example, let's say I'm doing an online course in, say, digital signal processing. Okay, so how do I practice my labs? Okay, I can't go travel, 10 kilometers away and go and practice labs in a particular institute or university. So by virtualizing the entire thing, we can make the entire thing scalable in terms of adding practice to such online learning, schemes that are there. And for example, we've got customers who use it for classroom teaching. So we effectively think that the way classroom teaching happens today with PowerPoints, etc., are not interesting enough, because as audiences, by just looking at PowerPoints the way that you're doing right now, you lose interest after some time. Especially if you're talking about a very large class. For example, in engineering today, you have class sizes of 500, 600 students, all seated in a large hall looking at PowerPoints. Okay, and I'm sure 90% of them fall asleep, right? So the whole idea is, how do you make classroom teaching more interesting, right? So we say that bring in virtual labs inside classroom teaching, where you can effectively explore and simulate situations in the classroom. Okay? Then the last thing that we've been able to do is to tie virtual labs to assignments. So this is something very interesting, right? So up till now, virtual labs in a lab, let's say a physical lab in a lab setting, is where you would construct an experiment and you would visually observe. Somebody will come and visually observe and say that, are my results correct? And will grade you according to that. The key interesting piece of technology that we've developed in virtual labs is the ability to automatically assess and evaluate things that you do virtually. So let's say I tell somebody to design a circuit. I tell somebody to design an audio amplifier. Or let's say I tell somebody to design a particular embedded application with a stepper motor. How do I automatically evaluate the design and say, this person has done it correctly? Okay? So we've been able to create technology with which a virtual lab could be used for assignments as well, and automatically kind of correct them, grade them, understand what the student has done. Okay? So this is primarily where we have seen uses of virtual labs, and we've been able to kind of have proofs and case in points in each one of them. Okay. So let's talk about 2 or 3 of our of something that we've been. For example, we've been very successful at kind of putting virtual labs in teaching. Okay, where and teaching, not only kind of blackboard teaching, as I said, online teaching, and also distance learning. Okay, where For example, distance learning today in India, you don't do technical courses on distance learning, but if you look at the Phoenix universities and the DeVry University models outside India, a lot of distance education happens in online, in technical courses as well, and they need effective ways to teach there because they don't have just chalk and blackboards out there, right? So we've been able to use systems to kind of customize them for teaching, integrated them with whiteboards, etc. And we've been very kind of we've successfully demonstrated learning and retention improvements in classroom based on using such technologies. Then, as I said, we've been able to use it by, to complement labs. So what we do is we work with specific universities, colleges, etc., and we customize the virtual labs for a particular syllabus, for a particular curriculum, so that outside of the lab, people can access virtual labs 24/7, be it from their homes or their hostels, and they can effectively practice modules that they are learning in theory. Okay, and we've published papers on this where we've been able to prove effectively that their sense of application in practicing in a virtual lab, complementing the physical labs, goes up by 40%. Okay. And we've been able to kind of demonstrate this over a various set of courses, like for example in courses in electronics, computer science courses, and mechanical courses. As a company, we are mostly focusing on higher education. Okay, so what I wanted to do is show a small demo of our electronic solution to you, just for you to kind of get an idea of how this exactly kind of structures out. So this is a cloud-based app that we have, and every student or a teacher gets a unique user ID and password, and they can sign up as well. And I'm just logging in with something with a universal. So we have, let's say, this we did for a first year course in one of the colleges. I forget the name. I think it was Pune University, where one of the first year courses we completely virtualized in electronics. So let's say, so this is where we tie it up to the curriculum as a dashboard, and let's say we are looking at simple solution called RC circuits. What we present the student with, for example, in electronics, is a virtual breadboard and a learning wizard with very clear outcomes. So the entire instruction methodology is structured in Merrill's approach, where we start with activation, and then we go to demonstration, and then the application part, where we want them to actually, once they learn the demonstration, they should be able to go and apply and create a similar kind of a circuit on the breadboard, virtual breadboard, which happens by kind of dragging and dropping components, and then kind of connecting them by wires, etc. Just kind of show you a demo. So this is typically what you do in an engineering lab, and this is what we kind of try and provide an environment for in the virtual lab as well. So what I'm doing is basically connecting wires, joining these components, putting grounds, etc., and changing. So all these components are built like real interactive components. This is how a function generator looks like in real life. You switch it on, and you should be able to go change and tweak it, tweak it the way it's supposed to be done in a real lab. Okay, and kind of configure this. You can configure components the way you would do, for example, a resistor. You want to use a 1 kilo ohm resistor, for example. Use that, the color of the resistor changes and all that. Particular capacitor, you use that. And what you would do is then kind of, after you've built the circuit, you'll essentially run simulations and view the results in a oscilloscope or data analyzers. So even things like oscilloscopes are kind of created like real oscilloscope. You switch them on, And just like you would use a real oscilloscope in a lab, you would kind of end up using this. And all these different instruments like DC sources, etc., have been designed just to kind of look like real-like instruments. And the whole idea of the wizard is which will guide you step by step to understand, and in each step it will prompt you to do an activity on the virtual lab and kind of ask you questions in a problem-based learning manner, and kind of end with a post-test to actually test the outcomes that were laid down previously in a particular mode. So I'll just kind of close the demo because. So this is one of the examples where we've done it in electronics. Similarly, we've created virtual labs in kind of programming where we provide them automated step-by-step practice modules. And the whole idea for programming is when you write a program, we have technology to evaluate a program automatically and say whether, let's say I give you a binary sort program to write, I can test it out automatically and say whether the program that you've written is correct or not, where you've gone wrong, which test cases it doesn't pass, and stuff like that. So if completely automated programming, support a lot of programming languages, and this is being used as a platform not only by students in their lab assignments, but also as self-learning modules to learn from a virtual lab point of view. Similarly, we've kind of done things in engineering, drawing, etc., and control systems and mechanical. Okay, we have papers that have been published in T4E, in IEDC, in SFO, in SFO conference that's happening in March 19th, in Indian Science Congress, where we've proved, where professors who've used our tool, they have proved that 40% improvement in learning and retention when you use virtual labs by complementing it with physical labs in some of the forms that I kind of described. So very short presentation, wanted to kind of stick to the time. So yes, question?
My question is that in the field of engineering, certain concepts can get a little complicated, right? So some students are bound to have a few doubts about fundamental concepts, and if that doubt isn't cleared, you won't be able to move forward in a particular topic. So how do you plan to counter that problem?
Yeah, so for what we do is, for most of the courses, we lay down a small refresher or a bridge course, okay, which consists of some familiarization modules with very strong outcomes. And unless the student passes the assessments of the bridge course, okay, we don't let him get into the main course. Typically, that's how we do it today.
That blocks the learning process, right? How does he clear his doubt of a particular topic?
Okay.
If he's studying something.
So can you take that offline? It's time for tea and we're running a little late. Thanks, Debabrata. Thank you so much for your presentation. And thanks for sticking to some time limits.